Question number 17 is about logarithmic expressions mainly, and they're not so simple because there are questions where you need to analyze, understand, and then draw conclusions. We'll look at all the problems. Here now we have a real world problem about earthquakes. The intensity of an earthquake can be measured on the Richter scale using the formula y equals 10 to the power r minus 1, where y is the absolute intensity of the earthquake and r is its Richter scale measurement. In 1906, an earthquake in San Francisco had an absolute intensity of 6 million. What is the Richter scale measurement of the earthquake? Over here, they have told, see, based on the absolute intensity, if there's only one, it's just one Richter scale number. If it's, say, 10,000, it's 5, and so on. Now, how we solve is they have given the equation over here. So all we need to do is start with that equation. So we need to substitute all the given over here. uh, y equals 10 to the power r minus 1. Now they have mentioned here y is the absolute intensity and they have given us absolute intensity. So let's write it 6 millions. So 6 million, that is equal to 10 r minus 1. We need to find r, the Richter scale number, where r is Richter scale measurement, right? How do we solve this? Now, this is not with calculator. If you put in calculator, yes, you get the answer. But here you need to do manually. So whenever you have something to the power, how do you bring it down? It is from the inverse of this exponent. This is an exponential, right? Inverse of this is log. So take log on both the sides. Log what base? Log base 10, because here that'll be cancelled. What is the base here? Exponent's base is 10. So take log base 10 of 6 millions, and that is equal to log base 10 of what? 10 to the power r minus 1. Now we have to apply the rules of log. What are the rules of log? Whenever there is an exponent over here at the right side, any exponent, it becomes the coefficient. R minus 1 comes down and you're remaining with log 10 base 10. Base 10 and 10. Now here, what does log mean exactly? Let's just take a minute. Like, you can stop over here. Let's take a minute to understand log. If I have log 49 base 7, what does this mean? This actually means how many times I have to take the power of the base. That means how many times I should take the power to get 49. The answer is how much? It's just 2. Why? Because 7 square is 49, isn't it? Now the same way we can easily convert this. How to convert this to exponential form? Now imagine you don't know the answer, unknown answer. This base goes and becomes the base of exponent and this moves up. So you will have 49 remaining. This is gone, equals 7 to the power x. That is the conversion from logarithmic to exponent. And now what is x raised to power? Only when it is 7 to the power 2, it's 49. This is the answer. Same way, you can convert from exponent to logarithm. How do we do it? Now imagine this was x. Yeah, over here only we have, right? Now I needed to write in log. All I do is this base goes to the other side and becomes the base of log 49. That is equal to, this comes down, the power comes down, and that's the answer. Anyways, this is just for understanding. So here, how many times do I have to raise 10 to get 10? It's 1. Whenever you have these same numbers over here, base and this, it cancels and becomes 1. The answer is 1 over here. Let's leave it for now. And over here, the same thing. How many times do I have to raise this to make it 6 million? So you need to think about it now. We will just use the calculator for this because it's going to be not so easy. If it was 1, then yes, we can just count the powers, the number of zeros, and easily do it. But it's 6 million. So what we will do is we'll use the calculator. But as long as you've written this, it's okay. Here we just put log base 10, or you can use log. Normally log is having only base 10, but we have this option anyways. Specify the base, and it's 6 million. 6 and 6 zeros. 1 2 3 4 5 6. Yeah, that's the answer, right? Yeah. Now it is 6.77. You will have your calculator so you can check it out, but generally they might mention this, okay, because it's not that easy to remember this. So they might mention it, or you can just use your calculator and check. So what I'll write is, over here, this left side is basically 6.78. Now what happens over here? This is equal to 1. So 1 into r minus 1 is only r minus 1, isn't it? So it'll be 6.78 equals r minus 1. This minus 1 goes to the other side and becomes 7.78 equals r. And this is your answer. That's it. So I hope this is clear. Let's just check the answer. Yeah, it's 7 point. Okay, it's 7.8. That's the answer. This conversion is crucial. Now over here we have another problem in about investing. Maria invests $1,000 in a savings account that pays 4% interest compounded annually. The value of the account A after X years can be determined from the equation A. Equation A equals 1000 times 1.04x. Solve the equation. They have given the equation. There's nothing to worry. I thought we have to know the interest formula and everything, but no, nothing. They have just given the equation. All you need to do is solve this. So we need the value of the account A after X years is given over here. Here we just have to solve this, simplify this equation and get it in terms of x. Okay, that's the thing. So what we can do is we can take this 1000 to the other side. First, let's divide by 1000. Let's keep this alone, the exponent. So it'll be 1000 over here, and this 1000 gets cancelled. So 1.04 power x. Now take log on both the sides. Log, what I would do is I would take log base of 1.04. You can do this. Then over here what happens? It'll be log base of 1.04 of 1.04x. Now this is all equal to 1, and you're remaining with only the x. So x will be equal to what? Log base 1.04 of a by 1000. That's it. Let me just check whether this is the only thing that's done. Yeah, that's it. Okay. I thought there might be some other method or something. It's very simple. So always take the base of log, whatever is the base of the exponent. That's it. So taking both. Why do we do that? Because whenever we have log base a number and log of this also number, they both are same, this and this, then it's always 1. So this becomes 1, and you're remaining with the power. Power comes down, right? Is equal to x. Now this is the answer. Okay. It's a very simple one. Here another one is about, see, all are different types, so I will try to go through all different type of problem. If it's the same, I will just skip through it. Here we have a real world problem on construct arguments. Julio and Natalia are competing in a math competition. They each select a logarithmic function and compare their functions to see which has a greater value. Julio selected f of x equals 10 log 2x, and Natalia selected g of x 2 log 10x. Which of the function has the greater value when x is 7? Now it really doesn't matter what x is having the value. It matters about these, okay? What is the base? Before we begin, I just want to clarify a few important things of log, because this is very important. If you understand, see, because it's about explaining and reasoning, if you understand what exactly is log, then it's very easy to realize the problems. Now log, let it be any base. I'll take it as 100. Okay. Now this is, I like to write y, log first. Generally it will be like this. Y is equal to log base something. Now base can be anything, but I'll tell you what is the difference if it's a small base, if it's a big base. Let me take a base of 10. What does this mean? What does this specify? This means that this base is there, right? How much time should I raise it to the power to get 100? That is what it means. Now we know 10 to the power 2 is 100. So the answer for this, when it's base 10, I'll write over here, base 10, y equals 2. Okay, when the base was 10. Now let me change it up. Let's not take base 10. Let's change the base to say 9, 1 less. So now how much should I raise 9 to get 100? I know 9 to the power 2 is 81, so it must be more than 2, right? It might be 2.2. I have no clue whatsoever. This might be way wrong, but it's around more than 9, more than 2. That's what I know. So if it's 9, y is about 2.2. That's the thing. Now, what if I change this to say a smaller number 5? How many times do I have to raise 5 to get 100? I know 5 square is 25, but what about 5 to the power 3? It's 125. So I think so 5, it will be about y equals 2.6 or 7. Okay, let me just take it like that. Now let me go down still further. Let me take it as 3. How many times do I have to raise 3 to get 100? I know 3 cube, 3 square is 9, 3 cube is 27, 3 to the power 4 is 81. It's more than 4. It should be, for base 3, it's more than 4. 4 and plus, okay? Now what if it's base 2? It'll be 2 to the power 5 is 64. It's 5 point something, okay? Because 2 to the power 5 is 64. That means it should be 2 to the power 5.2. Maybe you'll get 100. More than that, I guess. So now it's, sorry, 128 is 6. So it might be like 5.5 or something. Now you're understanding, as I reduce the base, the y value, if you're graphing this, it increases. Okay, as I reduce the base. If the base is bigger, it is small. So now look at this. This is having such a big base, 10, whereas this is having just 2. Doesn't matter how much this is, your answer will matter with the base. Okay, now just for a simple understanding, we can check this in calculator as well. Let's take our calculators. Here, what we will do is we'll type in both the values. Now they have told x value is how much? 7. So 10 log base 2 x is 7. What is the answer? It is 28.07. Why? Because main concept is how many times you need to raise, but over here, since this 10 is there, it changes, but still it's 28.07. But now let's do this one. 2 log base 10 x is 7. It's 1.69. Can you see the drastic change? There is so much of a difference. So this is the thing. Now, why that matters is, now I will just let you know. Let's solve it manually. I'll take this all off. I hope you understood. As the base reduces, the y value increases. That means it's a greater value. Now over here, so here, if you're thinking of solving this, first let's just understand what this is. 10, let it be log 2 of 7. So how many times should I raise 2 to get 7? I know 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8. So it might be around 3 point something. Don't you agree? And it might be, 3 is 8. Sorry, it's 2 point maybe 8 or something. Okay, that's 7. So now this 2.8 is multiplied with 10. So you'll get 28. Now what about this? 2 log base 10 of 7. So here, how many times do you have to raise 10 to get 7? It will be something 0 point something, isn't it? 0 point, I'm not sure, 8 or something it might be. Now this thing, 0.8 is multiplied into 2, that will be 1.6. See, these are not at all accurate. I'm just doing it on the top of my mind, but just to give you an understanding, you can see the difference. So obviously this is bigger. When the base is small, the value will be bigger. I hope that is clear now. Now, to be honest, I don't know how exactly what they are asking. They're asking to compare the functions to have a greater value. See, now you can, whatever I just now told you, if you have written that stuff like this, and then you have told this is greater because of the, the base, as the base is smaller, it's much bigger value. That is more than enough explanation, that is a reasoning. Let's see what they are asking for. Okay, they are graphing both functions. Okay, explain your reasoning. Okay, you do not need to exactly graph, but if you know some basic things of the graph, as the base is bigger, the graphs are flatter like this. Okay, if it's this is small, it will go up and up. You can check it in Desmos. And one more thing, this value changes a lot. If this value is bigger than 1, it should be greater than 1. See, it's mentioned over here. It's always stretched vertically, it will go upwards. Okay, but here both are bigger than 1, so that is not a great thing. See, both are stretched vertically only. That's not that useful for us. But you can see this will be stretched more than this one. Is that is one plus point. Now they are using these points. Now there is a rule in logarithm. See, now this is y is equal to a log base b x. This is how we write log function. Okay, this is the standard form. Now, if you know the base, we know it's 2. If you take the inverse of base, 1 by base, the second point, this if this is the x coordinate, the y coordinate will always be negative whatever is there over here, negative a. This is how we can easily find a points in the graph. Now here for this case, what is the base value? It's half. Then it will be minus 10. If you graph it and check, you will get this. Okay. And what about the next one? Over here, if you take 1 by 10, then you will have minus 2. And then you can also find the other points. One more thing is, you always will have these 2 points in every logarithmic function. Every log will always have, because it's like this, right? It doesn't touch 0, but it's an asymptote. It goes like this. At x equals 1, it's always 0. Doesn't matter what. If you have understood log, how it works, the power and all, then you will realize. Let me just tell you why. Log base x a y. Okay, now let's take that a off. This is just for understanding. When we convert this to exponent, what happens? The base goes to the other side. It will be b to the power y is equal to x. Now, look here. When we want x as 1, so let's write x as 1. When do you think I should, what power should I raise this number to get 1? Doesn't matter what, any number, only when you raise it to 0, any constant, this can be any number, 1, 2, 3, anything, it must be raised to power 0. If this is a number, I should raise it power 0, then only I'll get 1, because anything raised to the power 0 is 1. That's why this point must exist in literally all the logarithmic graphs. Okay, this is one point. And the last point, this is, I told you, right, inverse 1 by b comma minus a, and then b will be a also. This is another important. I'll clear this all up because it's already there. Now over here, what is the base? Base is 2, a is 10, right? Now if you plot 2, you will have one more point as 10. At x equals 2, it will be 10. Okay, this is one more thing. So these are about the graphs. And that's it. Basically, they are doing the graphs and telling which is the higher point. From here, you can tell the first graph with the base, a lower base. At 2, look at what happened. At 2, x of value 2, let me just do this. X value of 2, the y value was 10. So it was something like this, big one. Whereas this graph, the bigger base, at 10, it will be at 2, isn't it? So it's something like this. That's another easy way to tell it. But if you have understood the relationship between base and the log, that's more than enough. We have spent a lot of time in this base because that is important. I hope you have understood the relationship between base. As the base increases, the value answer y value reduces. Okay, now over here, they are asking you when the x value is 1. Now, what happens when x is 1? We just now did it. It really doesn't matter. The answer is 0, right? So, neither over here for the second one, when 1 is there, we just now did it a while ago. I told you, right? So, now imagine y equals 10 log 2 and over here x. But x is 1. So, what you do is, let's take it to the other side. Y by 10 log base 2 x. Now let's take exponent over here. Wait, one second. Before that, before changing to the exponent form, we must know this is 1. Okay, x is 1. So we have to take this base to the other side. It becomes exponential in the sense 2 to the power whatever is this, y by 10 is equal to x. Now, what is x value? X is 1. If x is 1, what should be over here? Doesn't matter what, it must be the 0. So y must be 0. In any of this graph, even if I take this graph now, let me just do for the other one. Y is equal to 2 log 10 of x, right? Let me divide both the sides by 2. It will be y divided by 2 equals log base 10 of x. Now, exponential form. Usually, I prefer writing this term first, okay? Log 10x, then equal to y by 2. So why I do this is, so now I can see that this is going, this base of the log is going over there, x remains alone. 10 raised to y by 2. Now, it must be 0 here, only then x is equal to 1. Because we need x is equal to 1. So this must be 0. Both the cases, this doesn't matter at all, okay? When x is equal to 1. I hope that is clear. In the first one, we can, I had done this 27 and 1.7. If you just do that, it's enough, I guess. So whatever is there over here was extra explanation, see over here. But if you see the solutions, if you are just solved when x was 7, I had done approximate rough figure and I had done something. It was nearly 20 plus and over here it was 1.6 or something. That itself is enough to show. Or even if you explain saying that because the base is very small, very big, it is a lower value and base is small, it's a higher value. That's it. Now we move on to the 46th problem. It's about biology. An amoeba divides into two amoebas every hour. The number n of amoebas after t hours can be represented by t equals log base 2n. How many hours will it take for a single amoeba to divide into 2048 amoebas? Now, this one is related to exponent and log function. Here they have given the equation. So let's use that equation over here. And then they have also told how much it will be divided. What is this n? Number of amoebas, right? How much is it dividing into 2048? So this is the answer. Now all you need to do is convert this. Take this 2 to the other side. It becomes 2 to the power t and this remains. Now I will just write here. I personally write always the log function first. Log 2, n is how much? 2048 equals t. We have to find the t time. This goes to the other side. The base of this goes and this raises to the power. So 2048 equals 2 to the power t. Now you have to solve how many times you have to raise 2 to the power. If you know 1024, 2 to the power 10 equals 1024. I hope you might remember this. And then if you take one more power, 2 to the power 11, this will be multiplied by 2, right? So multiply this by 2, it will be 2048. So that's an easy number to remember. So t equals 11. It will take 11 hours for amoeba to multiply to so much. Just with a simple 2 amoebas, it can go on to so much, okay? Now then, over here we have been told to graph exponent and log function. Now if you know the exponential functions are something like this, they'll never touch the 0. Log functions are like this. And they are, reflected along xy, y equals x axis, okay? So this is a very rough figure. Over here we have, see this is the exact figure. Now we need to just tell the domain, range and everything. The domain is always all real numbers for exponent. Range is all positive real numbers. Whereas the domain for log is always from 0 to infinity. Okay? Only all positive real numbers. And what is the range? Range is from infinity to infinity. Here they have told intercept. There is no x-intercept at all for exponent because it doesn't touch the axis. But this over here, y-intercept is there. At x equals 0, y is 1. But whereas in log function, there is x-intercept. At x equals 1, y is 0. But there will be no y-intercept at all because it's a vertical asymptote. And for log, there is a vertical asymptote. For exponent, there is a horizontal asymptote. These are a few things. That's it. They have told all that. What have we just now discussed? It's all in detail over here. Looking at the graph, you can easily tell, right? Domain, range, all that stuff. That's it. And the last one is, see, they are the graphs have inverse relation with one another. They are symmetric along y equals x. Because if you draw a graph, a straight line y equals x means the slope is 1, you will get line over here in the middle. They are always reflected along that. Then we have, what should you consider when using exponential and logarithmic model to make decisions? To be honest, uh, I don't understand what they want over here. There are many considerations, the base, the power. So let's quickly look into the answer, what they are looking for. Exponent and log models can grow without okay, I understood now. This is very important. Now I remember that. Like, I mean, see, what happens in exponent over here? They will always go towards infinity. They just grow without any bound. They keep on growing, isn't it? The exponent, especially population explosion, happens in an exponential manner. Now, that models, if you are graphing like this, it'll just give you a model after so many years, it'll just keep on growing. It doesn't stop, it goes to infinity. But in reality, what happens? Now, say for example, there is food constraint or there is no space, then population cannot grow. So these are the things. Now, say for example, amoebas or bacteria in a lab. Now, only with food and with the microorganisms grow only when there is required amount of food, sun, all these factors, and there must be space as well, and then they multiply. If that is taken off, they are constrained, then it does not grow. So this is the thing you must understand. Exponential and log function don't consider that. They just keep on growing without any bound. That's one of the main things they have told. See, this is all understanding and writing. And now we have a problem about finding the composition of functions, right? We have been given f of x, g of x, and we have to find f composed of g of x. Okay? They are inverse of each other, so we must know the answer will be x, right? Let's do it. Let's just prove it. So we need to solve for f of g of x. What is the inner function? G of x. So substitute f of, what is g of x over here given as 10 to the power x. Now what is the function f of x? Log 10x. Wherever x is there, you should put 10 to the power x over here. So this becomes log base 10. Instead of x, you put this one, right? So f of g of x means g of x is 10 to the power x. Instead of this x, I put 10 to the power x. This is it. Now look, this comes down, x comes down, and what happens? Log base 10 of 10. This is 1, so x into 1, the answer is x. So that's it, that is the answer. You can see, okay, over here they are done exponential way, but you can do this method also. This is also the same thing, it's fine, the correct answer itself. The answer will be x, same thing. Now the same thing in the other side, you have to do again g of f of x. I'll just show you how do we do that. G of f of x, that means, what is f of x? Let's write it inside the g. It's log base 10 of x. Now this entire thing must be written over here, 10 to the power log base 10 of x. Here, this is the thing. Now, how can you remove this? You can take log on both the sides, like y is equal to so much. Take log on both the sides. It becomes log base 10, okay? Log base 10 y equals log 10 to the power log 10 of x. So here, this practically comes down, right? The rule of the log says whatever is there comes down. So we will have log 10 of y equals log 10 x, and then what is there? Log 10 and 10, which becomes equal to 1. This entire thing, because the base and this number is same. So over here now we have log 10 and log 10, so y is equal to x. Whatever is there, this is equated. If we have same bases and then whatever this number can be equated, so y is equal to x ultimately. So both the answers are x, they are inverse. So that's it. And that's the answer over there. And what else? Now we have some more understanding problems, I believe. So Betsy says that the graphs of all logarithmic functions cross the y-axis at 0, comma 1. That's wrong, right? Okay, let's, because the number to the 0 power equals 1, Tyron disagrees and he says log 0 is undefined. Yes, this is correct. Is either of them correct? Explain your reasoning. So let's just understand. Log functions can never have x of 0. Why? Because at 0 it's undefined. The log does not touch 0. It just comes over here like this. It's an asymptote and it passes. But it will always have 1 comma 0. It's not 0 comma 1. Okay. Over here, Tyrant says the log 0 is undefined. Yes, you can try putting log 0. What do you get in calculator? It's math error, undefined, because there is no value for that. So Tyrant is correct because you can just say it is not 0 comma 1, it's 1 comma 0, and over here it's undefined. So yeah, that's what it said over here. And log 0 is undefined. Now, persevere. Without using a calculator, compare log 751, log 861, and log 971. Which of these is greatest? Now, I've already told you about this, but the values are different. So let's check them out. But according to me, it's just a hunch that this is correct. Okay, because the base is small. Oh, but the values are changing. Okay, let's just try it. What does this mean? How much times you're raising 7 to get 51? I know 7 to the power 2 is 49. Then the x value over here, this should be y, not x. I'm sorry, that's y. Whenever, yeah. So y value will be around 2 point, say just little more than that, 2.1 or something. Okay, let's write 2 positive, because I can see over here these are all less than 2. Okay, so this is great only. Now what about this one here? How many times do you raise 8 to get 61? We know 8 square is 64, so it's less than 64. 1 is less than 64. So y must be less than 2. Less than, it's minus, so it will be 1.9 or something. And what about the last one? 9 raised to the power, how much is 71? We know 9 square is 81. So 71, yes, it should be less than 1 point something. It should be 1.9, or anyways, it's less than 2. So only over here we can see the value will be more than 2. X value is more than 2. You can try using your calculators also. You will get the answers for this more than 2. Over here it will be 1.9 and 1.9. That's the thing. So log base 751 is the greatest. So if you have understood the base and the relationship of log, then this is very easy. In fact, log is an easy concept, but it's a bit tricky. But once you understand, you will realize, oh, how easy it is, And now we have to write logarithm of the form y equals log base b x for each of the following conditions, where y is 25. So over here they have given this y equals log base b of x. You have to just assume y as 25 and solve. What do we solve for? I think so we have to solve for x. So this base, what I'll write is I'll write log base b of x equals 25. I'll take the base to the other side. It will be x equals b to the power 25. Okay. So whatever is the base raised to the power so much is the answer. That's it. Now b value is not given, so you can just leave it like that. Oh, wait a minute. Okay, they have assumed a value of b. You can do that, but honestly speaking, this is the correct answer. Whatever I just written, it's fine because they have not mentioned b. But here what they have done is they have assumed the value for b as 2, and you can put it in the calculator. 2 to the power 25 is such a big number. I don't know why do you want to do that. Basically, and then they have substituted the x value back over here. It's up to them. But anyways, what I'm trying to say is, this will be correct. I think so. They want the substitution. So I'll tell you what has been done here for the base, right? They have assumed a value. See, for this, they have just assumed a value of 2. X is equal to 2 to the power 25. The answer is a huge number. Okay, it's a huge number. I'll write huge number. So that is substituted back as x over here. So what they have written is 25 is equal to log base b of the huge number. That's it. That's what it is. That's how it has been solved. But honestly speaking, if you have done this, Write a logarithmic equation for each of the following condition. This is the logarithmic equation. Sorry, this is the logarithmic equation. This is it. This should be the answer. But if you want to find some value for b, just substitute and do it. Let's see how the next problem is. Okay, y is negative. Same thing, same question, just y is negative. So here you can, we won't consider, see, y is not given as 25, so don't consider to be 25. 25 is such a huge number, right? Let's take small number. You can't take 1, obviously you should, I mean, base can't be 1, sorry, this can be 1, but still let's take a bigger number like 2. Let's start with 2. Now then, what do you do? That's it. You can just take this to the other side. B to the power 2 is equal to x. Now, I think so we will just assume the value for b as well as 2. So 2 to the power 2 is x. That is 4 equals x. Let's substitute back in this equation. Oh, I'm so sorry. I forgot to take it as negative. It is mentioned here minus. Okay, y is minus 2. Now take this b to the other side, or I'll write log base x equals minus 2. Now it's easy. So I will move the base over here to the other side. It will be x equals b to the power minus 2. Now, since they're assuming values, let's assume this also to be 2. So x is equal to what? 2 to the power minus 2. X equals 1 by 2 to the power positive 2, or it's 1 by 4. So now we will substitute back all the values. What is b and what is x? So the equation, log equation will be minus 2 equals log b value is assumed to be 2 of 1 by 4. That is the answer. Let's see. Okay, now they have just assumed some other value. In the previous one, they took 2, so I took 2 over here. And now they have just taken 3 and 4. Okay, they're just increasing the values. Anyways, but don't worry, this whatever was done over here is absolutely correct. As long as you know how to do it, that's what matters, okay? I don't think so this will be asked in the exam. Or even if it is, you can write your own answer. This is not a specified answer. It's just that, see, let means you're assuming. This has been assumed as minus 3 in this problem, and then b as what? 4. I had assumed both 2 and minus 2. That's it, and that's why I got this correct this answer, which is correct. This is just different assumptions. Now they have told y is in between 0 and 1. Let me just see what they have assumed. I will take 0.5. Okay, they have taken, see over here, y as 0.5 and b as 2. And now we will solve it. We will do the same thing. We know the equation over here, y is given in the question, log base bx. Now, y is equal to 0.5 and base b was taken as 2. Now we will start solving. It's 0.5 equals log b is 2x. Let's take this 2 to the, I'll write log first over here. X equals 0.5x. Sorry, what am I writing? This is it. Now this base goes to the other side and it will be x equals 2 to the power 0.5 or half, that is square root, you know. X is equal to square root 2. Now we will substitute everything back to get the equation. So 0.5 equals log 2 of root 2. Let's see whether it's correct over here. Yes, instead of 0.5 they have written half. That's the same thing. It just matters on what is assumed, okay? Because I have not mentioned anything, you can just assume your own values. That's it. Here when x is equal to 1. Now, 1 second. Is it possible? This is, oh sorry, yeah, x. I'm very sorry. I thought the base was 1. X is 1. Yes, x is 1. The y value is 0. You don't even need to do it. You should know that. Anything you assume, doesn't matter which value. Okay, I'll just show over here. They have assumed 7, but I will assume some other value. You will get 0. Y is equal to log base b of x. X is 1. Y equals log. You can take any value. I'll take 100 just to show you it doesn't matter. 1. Now take this to the other side. It will be 100 raised to y equals 1, right? What should be y value? Doesn't matter what. Y value must be 0. Okay, y value must be 0. Only then it will balance. That's it. So the equation would be over here, y value is 0 equals log base 10 of 1. So whenever over here you have 1, you can try and calculate any base, it will be 0. Y will be 0. Now last one, x is 0. One second, x is 1. X cannot be 0 because it's, we know the log graph, right? See, x is, doesn't touch, it's an asymptote, so it's undefined over there, okay? It's not possible. So even if you solve, we'll never get a correct answer. You can't raise anything to get 0. It's just not possible, right? Anything you raise, positive or negative, you will get some answer. Even negative power will give you some value. It'll be more than 0, okay? So it doesn't matter what, it cannot be equal to 0. That's the end of this question. It was such a lengthy one. Question number 17. I hope you understood log better because it was all about understanding the concept of log. So take time, understand log, and then try to solve and understand problem. First, understand what the base does, what the other values does, how to convert to different forms. If you know that, then you can easily solve these problems.